All right, 3.2, I think this is part one. We're going to learn a new method for solving a system of equations. We're going to use a method called combination. So our goal is to solve a linear system using combinations. All right, remember what a system is. Is just a group of two or more equations, right? So here's an example where there's just two equations with the x and y variables. Right, so normally you have like two equations and two variables, but technically you could have more than two, but two equations and two variables. And then when we solve it, we're going to find an xy pair that works for both of the equations. So back in this example, we want an xy pair where 2x minus 3y is 12 and x plus 3y is 3. Right, we're looking for an xy pair that fits both of those equations. All right, and we're going to learn our second method today called elimination or combination. All right, and you'll see why it's named that here in a second. All right, so this method works pretty well when the equations are stacked up like this, so they're both in standard form. And here's the steps. All right, so if you want to write down these steps, you can. Honestly, I think it's better just to have the example questions here and in the work that goes along with them, but if you want to write down the steps, you can. All right, so the first step is oftentimes the trickiest actually, is you want to get, so either the x's or the y's will add up to 0. So in this particular example, this one is one that's set up really nicely for us because we have positive and negative 3y, so they add up to 0 right away, right? But if that's not true, sometimes you have to multiply the equations by like 2, or one of the equations by 2 and the other one by negative 4 or something like that. All right, so just some more examples here, right? Like you'd want, say, 3x and minus 3x, because that would add up to 0, or like y and negative y, right? You need one of the variables, either the x's or y's, to add up to 0. Okay, and once you get that, step 2 is you're going to add them together, and then they'll eliminate. So in this case, positive 3y, negative 3y adds up to 0. So we get 4x plus 2x, no y's, and then 16 plus 8. Okay, and you can see why this is valuable because now the y's are gone, and boom, we know x, just divide by 6, and we get x to be 4. Okay, and so that's kind of the first part of our answer. Remember, our solutions are going to be like xy pairs. So we have x4. Okay, and so to find y, we've got to plug this into either one of our two equations. Doesn't matter which one, but I'm going to use the top one because there's no negatives in there, so I'm going to use this top one. So we have 4 times 4 for x plus 3y needs to be 16. And you can maybe start to even do this mentally, but y should come out as 0 here. So if we solve that, multiply 4 and 4, subtract 16, and then just divide by 3. So nothing divided by 3 is still nothing. So our solution is x4 and y 0. All right, so here's a second eliminations question. If you feel comfortable, pause the video. If not, I can walk you through the first steps, and then you could maybe pause along the way once you feel like you got it. I can't stress that enough. Doing these along with me, trying them, thinking about it, that's what's going to really help you learn this concept. Equations are stacked again, and if you look, if we added them together, one variable wouldn't eliminate. We'd have an x here, we'd have 2 y's, and then we'd have 7. Okay, so it's no good right now because neither variable disappears. All right, so we got a couple options here. We could take the second one times 2, because we have positive 2x and negative 2x, right? Or we could take it times negative 1, and then we'd have positive y and negative y. Okay, so it really is whatever you want to do, but I think I'm going to take this one and just multiply by negative 1, so that the top one is still the same as before. Okay, and the bottom one will still be the same equation, it'll just look different now. So it'll have a positive x, a minus y, and then positive 1. Okay, now we can add them together because now the y's will disappear, right? These cancel out. So we have 3x equals 9, and then boom, we know x, we're halfway there sort of, x is 3. Okay, and now that x is 3, we just plug it into either one of the equations. I'll use the top one again, I guess. So we'll have 2 times 3 plus y needs to be 8. So we get 6 plus y is 8, which means y has to be 2. So our solution to that system was x3 and y2. Right? And if we want to write it as an xy pair, we could write it that way also for our answer. All right. Again, I'd pause the video and see if you can do this one at this point. And hopefully this one's accessible to you now. So give it a shot. If not, you can unpause it and watch at least part of the answer. Tricky part here is, again, the x's and y's don't add up to 0, right? If we added these together, we'd have positive 6x, negative 1y, right? So neither one eliminates. So the trick is you want to look like, is there an easy way to get them to be so that they'd add up to 0? Positive 3 and negative 3, or 4 and negative 4, or something like that. And if you look at the y's, there's no easy way to go from 2 to 3, from the smaller one to the 3. You have to multiply by like 1.5 or something like that. But if you look at the x's, right, if we just say, hey, to go from 3 to 9, all we got to do is multiply by 3, and that's great, because then we'll have one positive and one negative. So taking the first one times 3 makes this question go really smooth. So as long as Mr. Westphal can multiply 18 times 3, which would be 54, I think. All right, and then the bottom one we're going to keep exactly the same. Sometimes you multiply both, but in this case we keep the bottom one exactly the same. Okay, now when we add them together, okay, we get 0 here, and we get positive 3y here, and then add those together, we get 9. Now divide by 3. So y is 3. Okay, and now we just got to find x, so use any equation you want. Maybe I'll use the bottom one this time just to mix it up. So I'll have 9x minus 3 times 3 equals negative 45. And so we'll get 9x minus 9 equals negative 45. And then add 9. And then divide by 9. So that would be negative 4. All right, and please know, like, if you're not sure, right, if you get here and you're like, man, I feel like I made a mistake or something, you can plug it in and check. So if we check like x being negative 4 and y being 3, we can see, does that work out and make a true statement? So here we'd have 12 plus 6 is 18, so that seems okay for the first equation. Now try the bottom one. 9 times negative 4 minus 3 times 3 is at negative 45. So we'd say negative 36 minus 9, that looks like it equals negative 45. Okay, so that's a way we can check, right, that our answer works for both equations. Okay, so this problem represents the hardest type, and the reason is, there's no easy way to go from 2 to 3. We can't just multiply by 2 or 3 or 4 or some whole number. It's not a multiple, right? These are not multiples of each other. Same thing with the y. There's no easy way to go from 4 to 5. All right, so this is the hardest type, where you have to actually multiply both equations by a value. All right, so pause the video and see if you can do the first step here. You're going to multiply both equations this time before doing your elimination method. Okay, so it's kind of like a common denominator. You can do like 3 and 2 for the x's, or you could do 5 and 4 for the y's. So I'm probably just going to do 3 and 2 to give us 6x and 6x. And then the only trick is I want one of them to be negative 6x. So I'm just going to do one of these as negative. So rewriting, then the top one becomes 6x minus 12y equals negative 18. And then the bottom one, negative 6x plus 10y equals 14. Okay, and now add these together. So the x's are gone, that's what we want. Negative 2y equals negative 4. Divide by negative 2, and we got y2. Plug it into either equation. So again, I'll just do the bottom one here. So we have 3x minus 10, 5 times 2. Add 10 to both sides. So we get, I kind of messed that up, but we get 3x equals positive 3. and then divide by 3 and we get x1. And boom, we solved our system. All right, the final piece to this then is just to do this with story problems. So I'm going to do at least one example here at the end where they don't give us the equations, but you have to take a story problem and write the system of equations. All right, and so this is from a story from the soap factory. It's getting around Halloween time, and I've always heard this is like the most terrifying haunted house ever. And so I don't really know much about it, but we're gonna do an example made up about that. So they made a bunch of money and they had 321 people. The adults were $6, children's. I don't know why they have children's at this thing. I hear it's terrifying, but in this fictitious example, we have children's price of $4. So how many adults and children were admitted? All right, so that's our first step, sort of, is that our variables x is like the number of adults or the number of children, however you want to do it. We'll just say adults, and then y is going to be the number of children. Okay, and so as far as to get the equations, I'm going to get rid of this thing quick, soap factory, just to save some space. Okay, so one of the equations involves money, and that's usually the easier one, right? So if it's like $6 per adult and $4 per child, we know that the total came out to be $15.90. Okay, and then the other equation is the harder one, and it involves just the tickets that we sold. All right, and so the tickets here are, we know that the total tickets is 321, and we sold X adult tickets and Y children tickets. All right, and so together, if you add those together, adult plus child tickets, it has to be 321. All right, so that gives us the two equations. All right, and I don't think I'm actually going to take the time to solve this because I think we've done that enough on the other examples. Maybe I just have you pause the video and say, you know, how would you start this? How would you get them so that the x's or the y's would be gone? Okay, and hopefully you figured out you can take this equation because it's 1x and 1y. It's easy to get it to cancel with these. You could either do -4 or -6. All right, so if we did -4, it would look like this. And then 321 times 4 would be 1200 plus, to be like 1284, I think, and negative. Okay, and then you add those together and boom, you're on your way. All right, so I'm not going to do this whole one because I think you got the hang of that. The harder part is writing the equations. So I'm going to close with one more example here. Right, we are going to a coffee shop. You can read through it and then see if you can come up with the two equations and unpause the video to check your answer. Okay, so your two variables are the large cups and then the regular. All right, and so again, we have one cut with money, right? Because a regular, actually a large, so the way I set it up, the large is 150, and the regular is $1, and we know that it comes out to be $6 total. All right, and then they buy 5 total. So again, you have just like an x plus y because the regular ones plus the large ones, or sorry, the large plus the regular has to be 5. Right, so that's going to be your other equation, is just adding them together. You have a total of 5 cups. All right, that is it. So again, we'd have to solve this, but I'm not going to do that here. Just I think you got enough practice with that on the other example. So just know that on the story problems, you have to write them, then solve. All right, that's all. Thanks for watching.